everyone. So today we are from Group 2. We would like to present about the valorizing kitchen waste through bacterial cellulose production towards a more sustainable biofuel. The economic growth has resulted in massive population growth, which will increase the solid waste. This is because most human activities generate some form of byproduct in a solid, liquid or gaseous form. Traditional methods of kitchen waste disposal, such as landfilling, have the potential to pollute the environment and harm people. Valorizing kitchen waste has achieved various amounts of success with the goal to minimize waste disposal volume and eventually protect the environment. To make a better fermentation process for bacterial cellulose production from kitchen waste, a useful lesson to integrate a multi-product biofinery of a wide range can be consulted. This is because it has more complex composition and chemical structure to see the effect of residual salt and cooked oil. So next, I will pass the presentation to Intan. Thank you.
Okay, so for the methodology, the first step is the pre-treatment of kitchen waste. The tap water was added and the solid fraction then being sterilized in 121 Celsius. The liquid fraction was separated into the cooked oil and wastewater. So the second step is the enzymatic sacrification. Solid fraction was hydrolyzed using these two enzymes, and the liquid fraction was separated by filtration. The next step is the BC production. The glucose concentration of the resultant hydrolyzed was diluted, and these substance, you can see the peptide, yeast extract, etc., were added. The liquid production medium was prepared with added glycerol, which act as carbon source, and sodium chloride and the separated cook oil were added. The liquid production medium was inoculated and cultivated, and the residual concentration of glucose or glycerol was determined. For the analytical method, the total solid and volatile solid of kitchen waste were analyzed. The starch content, the residual of salt and cook oil, the concentration of glucose and glycerol were determined. For the bacterial cellulose characterization, it was characterized using the freeze-dried BC films in terms of crystallinity, tensile property, surface morphology, and thermal stability. And for the last analysis, it is analyzed using the software of SPSS, and the test of one-way ANOVA and Duncan multiple range test was applied. So for the result and discussion, I'm handing it to Dayang.
Okay, thank you so much, Intan. For this part, we will discuss on the effect of residual salt and cooked oil on the BC production. This involves the simple water washing process before valorizing the kitchen waste into a more sustainable biorefinery. As you can see here, the utilization of reduced amount of sodium chloride and the used oil were the crucial part of the valorization of the kitchen waste. Depending on the amount, which differently will affect the yield of the BC. This can be seen in the figure 1A and 1B, which both prove that increasing the amount of sodium chloride and keeping the density of the cooked oil low will decrease the BC yield potentially. And to discuss on the effect of the production of BC characteristics can be divided into four characteristics, which are the BC morphology, tensile strength, crystallinity, thermal stability, and its mechanical performance. Figure 3 shows this SEM image of the BC produced from 0.04% and 0.34% of sodium chloride medium, despite a significant difference on the microstructure in which more complex surface was observed on the yielded BC from 0.04 sodium chloride group, implying a better structure of bacterial cellulose at the lower residual sodium chloride. In figure 4, it can be observed that the tensile strength of the yielded BC has significantly increased with the lower percentage of the sodium chloride. With the reduction of sodium chloride, the crystallinity was increased from 30.1% to 57.4%. And also, the decrease in the crystallinity index also affect in the lower thermal stability of the BC. The content of cooked oil also affected the degree of the crystallinity. And also moving to the performance of the BC production with the utilization of glycerol. Glycerol, which was obtained from the biodiesel, was also used to observe whether it could be a good option in producing BC. And table 3 here shows that the approximate increase of the tensile strength by 2 folds higher from the use of glycerol compared to the use of the glucose-rich hydrolyzed. And KW valorization has been very useful to produce quite an amount of products, enabling the multi-product biorefinery process. As you can see in the figure 8, from the kitchen waste, it could be valorized to produce a biodiesel, biogas, biofertilizer, and the bacterial cellulose itself. And moving on to the conclusion, we continue with Intan.
We can conclude that kitchen waste valorization has appeared to be an integrated multi-product biorefinery with the production of BC, in which we are able to conduct the daily process of kitchen waste production in urban areas. Well, I think that's all from us. Thank you.